So welcome back to the second part of the procedural donut creation in geometry nodes. Last time we ended up here. We have the dough and we made all of this. We made the base of the donut, we UV unwrapped it, we made some displacement, and then we made sort of this middle section. And now we're gonna start working on the icing of the donut. So we're gonna just move this to the side. We wanna create a second piece of mesh that's going on top of this, and we want it actually to be the exact same shape. So to do this, it would be logical to take about half of the donut and like duplicate it, and that's exactly what we're gonna do. So to do this, we wanna delete some geometry off of this. We're gonna get a delete geometry. If I put this in here, everything goes away because there's this selection value. We can select what to delete and what to keep to define this, so that it will always be the same based on the scale of the donut. So your radius, your major and minor radii would always be relative to the major and minor radii. Delete a certain section of the donut. So we're gonna actually use kind of the same setup as over here. So we're just gonna take that and copy it over here. And for the geometry, we're gonna need this geometry over here. So let's do the same kind of setup as last time, like so. And let's look at this. So what we want to do is actually, we can keep it exactly like this and use a less than a node. It's a compare node that's set to less than, and then if I increase this value, you will see that it starts to delete the donut, and we're gonna go to somewhere like this, and we're gonna delete just faces, not points, and just find a value that works. We kind of want to avoid this kind of thing. 0.7, like that. So there we have, and we can just check through some seeds. There's gonna be some that actually may be a good thing. So then we have this sort of section of the donut. If we now take this geometry and the geometry before and put them through a join geometry like so, and put this into here, you will have the donut, and you can see kind of that there is this thing here. Second piece of geometry on top of the donut that we're gonna join together. And let's actually pull this down here, put that instead. So keeping it clean from the start, so that it's easy to read and find where you have done all the things that you want to do. So let's just keep an eye on this for now. So this is the base of the icing, and to give it some thickness, we can just use an extrude mesh node, and you will see it creates these spikes. Kind of looks like hair, but this is not exactly what we want, because this is now extruding each face individually. So if I untick the individual, you will see that now it just creates a solid mesh. It is non-manifold, and we will fix that later. But this offset value here is gonna be the thickness of the icing, and we want that thickness to be really thin, probably 0.0, like 1. Oh, we're gonna put it to like 2 millimeters thick, and we can now look at that together. Yeah, something like that. That is already looking a lot like a donut. And you can see how it's like shaped on top of all of this. Like it's following the shape of the donut perfectly. But we want to create some drips on the donut. To do that, so we're gonna, before we extrude this, give it thickness, we're gonna extrude mesh prior to that. So let's look at this, and we're gonna set this to edges. And now it's important to figure out what is the direction and also the selection, because we only want to extrude from this outer edge of this mesh, and we need to sort of find that edge. So to do this, we're gonna use a node edge neighbors. It has this face count, and if we greater than 1, you can see that we get this black edge, black perimeter, and everything else is white. And to reverse this, we're just gonna type in not. So it's a boolean math set to not. See, so it's now extruding the edges of the perimeter of the icing. And then we're gonna add kind of a noise to this, so we can use a noise texture. Put this again to a 4D and take the seed, and we're just gonna do an integer math and just add like a random value to it, so that the seed for this noise is different than the seed for this noise. And then we could add this also into the, let's do that actually. Let's add another seed value and call it icing seed offset, and describe offsets the seed of the icing. Yeah, sure. And we'll set that as a default to 1. Yeah, perfect. And we kind of want to make this probably a bit smaller. So if I look at this with this, we want to make it kind of more, so that it's going to be kind of the size of a single edge around. We're going to take the roughness down and then use a less or greater than, it doesn't really matter, and then just do this until it's kind of, we could use that. Let's do that also. So then we can do a boolean math. So when these two are true, we get drips. Like so. So then we can kind of determine yeah, that's perfect. Let's do a map range. Do this to like so. So we're gonna take this value. I'll explain this in a second, don't worry. Group input. And let's actually let's clean this menu also. So this is going to be called drip amount, and let's set this subtype as factor, and default is 0.5 and minimum of 0 and maximum of 1. And let's add a panel. So we're going to call this dough. And then a second panel called icing. So in the dough, we're just gonna get the major radius and the minor radius like that. And then in the icing, we're gonna put like so. And we'll keep this resolution in the seed outside, and we're gonna close both of these by default. So now we have kind of these menus here to easily and quickly find the individual parts that we want to adjust when we use if we use this in the future. But what's happening here? You get the drip amount, which is this value. Let's just look at it. So if it's set to 1, it drips, all of it drips, and if you set it to 0, none of it drips. So if I put it to something like 0.5, so half of the size, so it's 50-50 if it's dripping or not. And this is just inverting the value, so it's taking the value from 0, putting it to 1, and 1 to 0. We could have just had this as a less than, and it would have been the same effect. But we did it now this way. This is also important to learn because there is no invert node. There's no inverting of a single value in geometry nodes as of recording in 4.5 and prior. So this is the way to do it instead. Now, these are of course not supposed to fly out into the wild like this. We kind of want to direct them downwards, and that we can do with this offset value. So this offset determines like the direction of the extrusion, and if we use a vector, a constant vector, and set this to -1, the vector of -1 means down, so then it will go straight down. But this is going to cause an issue later on. So we want to do something slightly different. So we want to kind of add this together with the normal. So if I were to just add these together, they would go kind of like that. And we can, do a vector math and divide this by 2, sort of divide it by 2 to dampen the amount of the normal being taken into account, because we don't want these to go like into the other side, and we don't want them to fly out too far from the surface, because we're gonna next raycast these into the side so that they wrap the dough of the donut, so that they are not floating in midair, like they're running down the side of the donut. And then these are all the drips are the same length. So we're gonna use a random value to determine the distance randomly. And in the seed, we're just gonna take the seed input like so. And the minimum amount is going to be something really small, like 0.005. The smallest drip is going to be 0.005, and the biggest drip is going to be 0.02 maybe, like that. I just want a little fewer drips for this. We want to wrap this around the dough of the donut, because now if we look at, right, if I put this now into here, if we look at this, the drips are, first of all, very ugly, and they're just floating in midair, which we don't want. We want to put them onto the surface of the donut, and this we can do with ray casting. Ray casting will take a point on the, will take an input of a target geometry, and it will send out a vector from each point depending on the ray direction, which we have here. So it will, you will say, what direction should I look at, send the ray, and if it hits, it will give the position of that hit, and we can just tell that point to go to the position where it has been hit. So we can start by putting just a set position and hit position, and currently they are not hitting anything, so the position is 0. All of this this dough here, or this that's on top of the donut, is hitting, so they are not being put to 0, but we don't actually want to affect that at all. So we're just going to take this value here, the top, which is going to be the part that's been extruded, and put that in the selection. So it will ignore everything else but this edge that was out here. But the ray direction is actually going to be the normal. However, it's not gonna be the normal like so. It's actually gonna be vector math. It's gonna be the normal in the negative direction. So we're just gonna multiply it by -1. And here I can tell already that it is going pretty far. Well, let's see what that looks like now. So if I combine that and look at the dough, you can see now that the drips are like on the surface of the donut. That is a huge drip. Wow. Now, to make these smoother, we can actually set position of these and take the position that they have. So if I put this in here, nothing happens. It will just put them in their normal position. But if I do a blur attribute and vector, we can kind of blur these drips, and we don't want to blur it like super much, so we're just gonna take this and put it like 0.3, and at the end actually of all of this we can do it, well, we can do it here. We want to sort of subdivision surface, so we want to just subdivide everything to smooth it out, and now you can see that it's starting to look more like actual drips, but they're kind of too sharp. 0.2, like so. Isn't that fantastic? Make it a bit thicker, the icing, and it's looking great. So now we can say how much it's gonna drip, and if it all drips, it gets like this natural edge, which is actually really nice looking, I must say. So we can have just a few drips like so, and then we could actually also add into the group input sort of that, put them into here, drip min and drip max. Let's put the drip amount above, so now we can actually say like, hey, it can be longer. That's drip. The drip maximum drip can be longer and the minimum drip can be shorter, like that. So then we get more variance of the drippage. That's an interesting word, drippage. So let's go back. I really like the look of it before, like that. Like so. So now we have the drips of the icing. So now the last things we want to do is to, well, clean this up so that it's not a major mess. So we clean that up like so, and we can put a frame. Let's not take that, we'll just take this per frame and call it icing, like so. So now we have the icing done. As it all works, we can up the resolution, and it will also change how the dripping looks. So if I reduce the quality, it's gonna be less of them because it's actually taking the physical geometry. So you want to kind of find the resolution that you want to keep. And as we have the subdivision here, it's actually increasing the amount of geometry. And we're gonna actually subdivide the dough as well, just so we have equal density geometry, like so. So one last thing about the icing is that if I just look at the icing, you can see that it is just open. It's not a solid. So we want to make this manifold, and to do this we want to just, before we extrude this thickness of the icing, we would just want to take this icing, I can actually do, and join this with this and put that over here. So now we have a mesh here, but you can see that they're not actually connected. And the other thing is that the orientation of the face on the other side is the wrong way. So we will want to flip faces and just put it in between, so then the face is the correct way. And then before we subdivide, we want to merge by distance, like this. So now it's merged. But what happens then is it's smoothing out this edge, and maybe we don't like that. So what we can do is store what the edge is, and we can do it the same way as we found the edge of here of the icing, the outside edge of the icing. So let's look at what we get with this. So we have that value. That looks interesting. Let's see if I take this value and put it into the, oh right, we gotta, no. If I take this value and store named attribute over here and call it the bound. And yeah, let's put it like that, and then use a named attribute called bound and put it in the edge crease. You'll see now that it like sharpens up this edge. So if I take that away, it just sharpens up that edge on the inside and not on the outside, just on the inside, like so, creating the crease. Because if I were to just do this, it would sharpen all of the edges, which we don't want. We want just on the inside. And there we go. So that's kind of what we created today for the icing. This is now the result. So that's it for the geometry of the icing, and in the next part we're going to start putting some sprinkles on top of this, and then we will get into the texturing of this donut. So join me for that, and I'll see you next time.